2, 1, welcome back. Another example here with pH acidity. Now this one is an application to the human stomach, so what is the actual pH level? It turns out that normally what we have is that the pH acidity is around 1.5 to 3.5. So our stomach is relatively acid, and for that matter, if we wanted to be able to see and do some calculations, here's a pretty neat short example to show you how you can utilize and calculate the pH, and that will be with the help of logs, okay, and exponents. So let's take a look. So a sample is being tested to see if the levels are in the normal range, so between 1.5 and 3.5. It has been found that the pOH concentration of a sample is, as it's given, 5.02 times 10 to the negative 9 moles per liter. So we have a concentration of pOH. Find the pH level based on this sample and then round the answer to 2 significant digits. All right, so we'll do that. Now, in case you have forgotten about significant digits and rounding, I'll put up a link up above there for you in case you want to refresh yourself. Now, on the pH calculation level, so this is what we would have to do in order to set up this problem. So what we have given is basically the actual concentration of, this is of the OH negative. So this is what we have as a given. Now, if we have this concentration, and notice it's in moles per liter, so that's all great. Once we have this, we can certainly utilize many different methods to try to find out what the pH level is. Now, you may recall, so there is a few things that you should know. So first of all, the hydrogen ions and the hydroxide ions, so their concentrations, if you multiply them, they're always equal to 10 to the negative 14. So that's just coming straight from science and observations that we see. So that's one item that we can use to help us. So we can certainly substitute this in here, find the hydrogen ion, which is what the pH level is based on, and then we can go from there. Now, another way that we can go about trying to solve this is we can just go ahead and we know that, for example, our hydroxide ions, so in this case, this is just simply equal to 10 to the negative pOH. Now, you might say, well, I don't really want pOH. That's fine. Okay, you don't really need pOH per se, but okay, these calculations and the same thing happens within here. So this is my pH, which is what I would have preferred, but I don't have the hydrogen ion concentration. I could get it from equation number 1 there, and that's certainly the case, and then I can solve for pH. But what I'm going to kind of prefer to do is I'm going to use this, find the pOH, and then what I'm going to take a look at is the third equation, and that equation is simply that your pH plus your pOH is equal to 14. Or for that matter, if you want to know the pH, you can just simply isolate for that, and then substitute your pOH right in there, and you will find out what that pH is. So let's try to solve it in this particular way. All right, so starting with what has been given, so that is this right here. So I'm going to kind of take this right there. I'm going to copy it, bring it down, okay? And now with this, I do know that this is equal to 10 negative pOH. So that is something I certainly know. I no longer need this junk on the left. I can just simply solve this. Now, solving this, I can use logs, okay, on both sides. So log of base 10 of this 5.02 times 10 to the negative 9 is equal to, so it's going to be logs of both sides, 10, and this is going to be 10 to the negative pOH. And as you recall, this is from the log Okay, properties, and again, I can put up a link up above there to log properties in case you would want to review it. So this will fall off entirely. This exponent comes down to the front, so this becomes negative pOH. I can certainly calculate what this is, so let's try that. So this is going to be log of 5.02, and this is just times 10 to the negative 9. I can hit my equals, and I'm going to get 8, okay, negative point, notice 29929, etc. Now, within here, the two negatives are going to fall off, so negative and negative, and I have found that my pOH is equal to 8.29929, etc. Again, I'm going to be rounding this right here, so to two significant figures, but I'll do that when I find my pH level. So now that I have found my pOH, I can just simply use this right here and substitute that in here. So that's not very difficult to do for me now. pH is equal to 14 minus 8.29929. And for that, so once I have this, 14 minus 8.29929, etc., it's 5.700, so on, but I wanted two sig figs. So with sig figs, just two of them, this is going to be just 5.7. And that is my pH, and that would solve my problem. So this is great to be able to do this. So we've basically have found, okay, that this particular stomach, okay, has a pH of 5.7. Now, is this in the normal range? Well, if the normal range is supposed to be between 1.5 and 3.5, okay, so then something has happened in here that it's 5.7. Now, how likely is this? Well, not very likely unless there's really something happening within, okay, our particular system, and we can't kind of keep our stomach at an equilibrium point in between whatever it is set to. So for this, I would say no, it is not within the normal range based on the fact that we have our acidity around 1.5 to 3.5, okay, so give or take. All right, so thank you for watching. That is the example, that's the calculation and application of utilizing exponents and logs to pH and pOH. Okay, happy studying. Bye, everybody.